yesterday we looked at velocity. And velocity is just the slope. And on linear lines, we've always used 2 points to find the slope. And now we saw yesterday that we can find the instantaneous velocity, which uses a tangent line. And it's just finding the slope at one point on a line or curve. So today we're going to look at what's called the difference quotient. And this is the definition of the derivative at x equals c. And remember, the derivative was just another word for that slope for instantaneous velocity. So just to review, we can find the average rate of change by using the slope of a secant line. So if I have, I'm going to leave some space to write my formula, but then if I have my graph and I have a curve on it, and I have this point right here at C, and I have this other point right here at X, I know I have these ordered pairs of C and F of C, and X and F of X. So my secant line, if I drew a line through those points, would give me the average rate of change. So that's the change in Y over the change in X. That's another way to notate rise over run. The delta triangle means change. And then our formula would be F of X minus F of C, which we have seen it as y2 minus y1 over x minus c. Okay, so what happens if my secant line, the points get closer and closer to C? Okay, so if I have my secant line going through these points, and I then picked other points, to find the slope as an average rate, and I just got closer and closer to C. What eventually becomes of my secant line? Am I getting a better average of the slope at C? Yeah, because I'm getting closer and closer. And eventually that secant line becomes the what?
Tangent line?
Tangent line. And when we approach, so we just said X is approaching C with these secant and tangent lines until it became the tangent line. And if we approach something, what are we evaluating?
The limit.
The limit. So the difference quotient, which is the definition of a derivative let me start over. The definition of the derivative at x equals c can be evaluated by using limits. Because I know the average rate uses 2 points. But I know if I get closer and closer to c, I can find the exact instantaneous slope, or the derivative, at x equals c. And so the way we write that, so what we did over here, we'll write it a couple of times. We just found the limit as x approaches c of our average slope, f of x minus f of c over x minus c. And so the meaning of that is the instantaneous rate of change of f of x with respect to x at x equals c. So the limit as x approaches c of f of x minus f of c over x minus c is the instantaneous rate of change of f of x with respect to x at x equals c. And so I have a couple of different ways I can notate this. I can write it as f prom of c. And this is the slope of the tangent line. And we know the tangent line is at one point, it's instantaneous at x equals c. That's my x value that I'm finding the instantaneous rate of. So this is called f prom of c, and that is the derivative, or the instantaneous rate, or the slope of the tangent line. So we have all these different words for just finding the slope at one point. And so the difference quotient, we'll write it again, is f prom of c is equal to the limit of f of x minus f of c over x minus c as x approaches c. And that's also known as the derivative. And all that's doing is my secant line, which was my average rate of change, is getting closer and closer to becoming my tangent line, which will give me the slope at that one point instead of the average rate of change.
So we work from the right to the left?
Well, that's just showing, yes, you're getting closer and closer from being the secant line to the tangent line.
Okay.
Okay, so example number 1. Use the definition of the derivative of a derivative to find the value of f prom of c when c is equal to 5 and f of x equals x squared minus 8x plus 18. Write the equation of the tangent line. Alright, so let's reread it. Use the definition of a derivative to find the value of f prime of c when c is 5 and f of x equals x squared minus 8x plus 18. Write the equation of the tangent line. Okay, so I've read it. What's my question asking me? To write the equation of the tangent line. So anytime I see the directions to write the equation of the tangent line, I'm going to write that out. So I know that's y minus y1 equal to m times x minus x1. And so if I'm using the equation of the tangent line, I know I always need a point and a slope. So I need a point for x1, y1, and the slope, which is m. So once I get those pieces, I can answer this question. So first, what's my point? Use the definition of a derivative to find the value of f prime of c when c is 5. So that's my x value. So I now know my x value is 5, so I can get my y value by finding f of 5. So if I plug in 5 to find f of 5, 5 squared minus 8 times 5 plus 18. And what does that give us? 3. So my point is 5, 3. That's my x1 and my y1. So I've already got part of my answer. So now I need my slope. And my slope, remember, is f prime of c, or f prime of 5. And so we just wrote the equation for f prime of c. So let's start with that. F prime of c is equal to f of x minus f of c over x minus c. And so now we're just going to simplify it. I'm finding the slope at c equal to 5. So I have f prime of 5. And I'm going to plug in the equation for f of x. So I have x squared minus 8x plus 18 minus, we just found f of c to be 3, over x minus, what's my c value? 5. And now I just simplify all that. And I forgot the biggest thing in front of it. The limit as x approaches c. So this f prime of 5, can't believe I did that, is equal to the limit as x approaches 5 of, I really hate that I did that. I was so excited about finding the derivative at this point I skipped it. Okay, so f prime of 5 is equal to the limit as x approaches 5. Now I'm just going to simplify. So I have x squared minus 8x, 18 minus 3 gives me 15. Over x minus 5. And we just spent a whole unit on evaluating limits. I can't plug it in right now. So what do I do instead? Factor it. So what does x squared minus 8x plus 15 factor into?
X minus 5, x minus 3.
Good, so I have x minus 5 times x minus 3 over x minus 5. Now it cancels out. I can plug 5 in. And 5 minus 3 gives me 2. So f prime of 5 is equal to 2, which is my slope. So now that I have my slope, I'm going to go back up here. I just found that to be 2, and I can write my answer. This is the equation of our tangent line. So we write it as y minus, my y1 is 3. So see, once I've already labeled all my work, then I just have to look and see what I labeled. So y minus 3 equals, my slope is 2 times x minus 5. And that's how I leave the equation of my tangent line. Alright, so what does this look like? So I'm going to pull up the graphing calculator so we can see this. Okay, so we go back to y equals, and y1 on top, our function, x squared minus 8x plus 18. And then y2,
So do we need to change that into?
yeah, if
Point
you look
some
at it in
formula?
your calculator, you can just add that 3 over, so I can type it in as 2
Okay.
times x minus 5 plus 3. There's my quadratic. And 1, 2, 3, 4, 5. Here's 5. And that is my tangent line right there. So that's my slope. And that linear line has a slope of 2. So I know right there at that exact point, that curve has a change in y over change in x of 2. So there's lots of things you can do in your calculator too. Under the math button, number 8 is the derivative. And so if I wanted to find I'm not going to show you all that yet. Okay,
That was really confusing.
I'll wait till we get to more notation. Okay. So let's do another example. So example number 2. We have f of x equals x squared minus 3x minus 4. And I want to write the equation of the tangent line. At c equals 4. So I'm writing the equation of the tangent line, so my first thing I'm going to do is write it out. Y minus y1 equals m times x minus x1. If I'm writing that for my answer, what do I need?
Point and M.
I need a point, and I need m. My point, x1, y1, has what x value?
3 or 4.
4. And so I need to now find what is f of 4. So if I plug 4 in, f of 4 will be 4 squared minus 3 times 4 minus 4. Minus 12 minus 4. 0. So there's my point. And now I know I need my slope at 4. So I need to find f prime of 4. So I know f prime of 4 is equal to the limit as x approaches 4 of f of x minus f of 4 over x minus 4. And now we just plug in f of x, plug in f of 4, and simplify the limit and evaluate it. F of x is x squared minus 3x minus 4. F of 4 is 0. factor, x squared minus 3x minus 4. Into x minus 4 times x plus 1. And now I have just x plus 1. So if I plug in 4, what do we get? 5. So that is what f prime of 4 equals.
Also known as the slope, right?
So that's the slope of that tangent line. So now I'm gonna go back up here, and I'm gonna finish writing my answer. So I have y minus 0 equals 5 times x minus 4. And there's the equation of my tangent line. So anytime you need to write the equation of your tangent line, what do you need?
Point and a slope.
A point and a slope. And your slope is found by,
The derivative of.
yes, the derivative, f prime of 4. Okay, so I'm going to stop there for today.